If you're building anything on Ethereum or any EVM-compatible chain, MetaMask connection is usually the first real piece of user-facing infrastructure you touch. It's also where a lot of developers make choices that create problems later, picking the wrong library, using a deprecated API, or not handling edge cases that show up in production. This guide covers how wallet connection in modern DApps actually works in 2026, the standards behind it, the two main implementation paths, and what to watch out for once real users start connecting wallets you didn't expect. What's actually happening when a user connects? Before writing any code, it's worth understanding the mechanism. MetaMask injects a provider object into the browser at window.ethereum. Your DApp communicates with the wallet through this object, requesting account access, reading the current network, sending transactions. The wallet handles signing and key management. Your DApp never touches the private key. The connection flow has 3 steps. First, your DApp requests account access. MetaMask shows the user a pop-up asking them to approve. If approved, MetaMask returns the user's wallet address. Your DApp stores that address and treats it as the user's identity for the session. That's the core loop. Everything else, network switching, transaction signing, contract interaction, builds on top of that initial handshake. The multi-wallet problem and EIP 6963. For years, the standard approach was checking for window.ethereum and assuming it was MetaMask. That worked when MetaMask was the only browser wallet. It stopped working when Coinbase Wallet, Rabby, Phantom, and dozens of other extensions started injecting their own providers into the same window.ethereum slot. The last extension to load won, which was arbitrary and frustrating for users who deliberately run multiple wallets. EIP 6963, finalized in 2023 and now the production standard in 2026, solves this. Instead of a single window.ethereum object that gets overwritten, EIP 6963 uses a browser event system where each wallet announces itself independently. Your DApp listens for these announcements and gets a list of all installed wallets. The user then chooses which one to connect. MetaMask supports EIP 6963 natively, as do all major wallets. MetaMask. If you're building a new DApp in 2026, you should be implementing EIP 6963 from the start. Relying on window.ethereum directly still works for MetaMask alone, but it creates a broken experience for users with multiple wallets installed. 2 approaches: libraries versus raw API. You have 2 main paths for implementation. You can use the wallet API directly, window.ethereum calls, manual event handling, EIP 6963 event listeners written by hand. Or you can use a library that abstracts this layer. The raw API approach gives you full control and no external dependencies. It's appropriate for very lightweight DApps or situations where you need granular control over every wallet interaction. The downside is that you're handling all the edge cases yourself: multi-wallet detection, network switching, disconnection events, account change events, error states. Libraries handle all of that. In 2026, the 2 dominant options are WAGMI and Ethers.js. WAGMI supports EIP 6963 natively and handles multi-wallet detection out of the box. MetaMask. The setup takes 3 steps. First, create a WAGMI config that defines which chains your DApp supports and which connectors it accepts. The MetaMask connector is imported from WAGMI's connectors package. You specify the chains Ethereum mainnet, Polygon, Arbitrum, Base, or whatever your DApp targets, and WAGMI handles the network management layer automatically. Second, wrap your application in a WAGMI provider using the config you created. This makes wallet state available throughout your app through React context. Third, use WAGMI's useConnect hook wherever you want the connect button. The hook returns a list of available connectors, 1 per detected wallet, based on EIP 6963 and a connect function. You render a button per connector, and calling Connect with the selected connector triggers the MetaMask approval pop-up. That's it. Once connected, Use Account gives you the connected address, chain ID, and connection status anywhere in your app. Use Disconnect handles disconnection. Everything is reactive. Your UI automatically updates when the user switches accounts or networks in MetaMask.WagMe+1. WagMe is the recommended path for any React app in 2026. The developer experience is significantly better than managing raw API calls, and the library is actively maintained with the current MetaMask SDK integration. Ethers, JS. The Direct Approach Ethers. JS is a lower-level library for interacting with Ethereum. It doesn't manage connection state the way WagMe does. That's your responsibility. But it gives you a clean interface for working with providers, signers, contracts, and transactions. The connection flow with Ethers. JS is explicit. You check whether window.ethereum exists. If it does, you create a browser provider instance wrapping it. You call provider.send with ETH_request accounts to trigger the MetaMask connection pop-up. Once approved, you get the list of accounts and create a signer from the first account. That signer can now sign transactions and interact with contracts on behalf of the user. Ethers. JS version 6, current in 2026, renamed Web3 provider to browser provider. This trips up developers migrating from older code. If you're following a tutorial that references Web3 provider, it's using the older API. The browser provider constructor takes window.ethereum directly and handles the provider abstraction. For event handling, you listen to window.ethereum directly. Accounts changed fires when the user switches accounts in MetaMask. Chain changed fires when they switch networks. Both require a page reload or explicit state update in your application. Ethers. JS is the right choice when you need fine-grained control over Ethereum interactions. When you're building back-end services that interact with the chain, or when you're not working in React and WagMe's hook model doesn't fit your architecture. Common issues in production: MetaMask not detected. Some users don't have MetaMask installed. Others use mobile browsers where the extension doesn't exist. Always check for window.ethereum before attempting connection and provide a fallback, a link to install MetaMask, or support for Wallet Connect as an alternative for mobile users. Failing silently here, create support requests from confused users. Wrong network. Your DApp might be deployed on Arbitrum, but the user's MetaMask is set to Ethereum mainnet. The wallet_switch Ethereum chain method lets you request a network switch programmatically. If the user hasn't added the target network yet, wallet_add Ethereum chain lets you add it. Handle the error case where the user rejects the switch. Your DApp needs to stay functional and surface a clear message. User rejection. When MetaMask shows an approval pop-up and the user clicks reject, the promise rejects with a specific error code. 4001. Catch this explicitly. An unhandled rejection here shows the user a JavaScript error rather than a clean UI state. Account change mid-session. Users switch accounts in MetaMask while your DApp is open. The accounts changed event fires with the new account array. If the array is empty, the user disconnected. Your app should handle both states, updating the displayed address and clearing session state on disconnect. MetaMask SDK for broader reach. MetaMask SDK, separate from the browser extension API, solves the mobile connection problem. With the SDK, your DApp can connect to MetaMask on a user's phone via QR code scanning or deep link, even when accessed from a mobile browser that doesn't support extensions. The SDK also supports multi-platform deployment. The same integration works in Web, React Native, and Node.js environments. For DApps expecting significant mobile traffic, integrating the SDK alongside the browser extension path is worth the additional setup. What to test before shipping? Test with MetaMask not installed. Test with multiple wallet extensions active. Test switching accounts mid-session. Test switching networks. Test rejecting every pop-up. connection request, transaction, network switch. Each rejection should produce a clean UI state, not an error. Test on mobile, specifically using MetaMask's in-app browser, which has quirks compared to the desktop extension. Test with a hardware wallet connected to MetaMask. The signing flow is slower and has different error states. The connection layer is the first thing your users interact with. Getting it right means fewer support issues, fewer abandoned sessions, and a significantly better first impression of whatever you built behind it.